Okay, we're asked to evaluate the expression for the given replacement values. If any of these values were negative, I would strongly advise putting parentheses where the variables are prior to plugging in the values. But since these are all positive, we'll just go ahead and plug them in. So for x, they want 3.7. All right, and let's have our plus sign right here. Okay, that simply comes down. Then for y, we've got a 5. And our negative sign is going to sit right here. And then for z, we have 57 hundredths. All right, and we'll start out combining our two positive values. And usually I do my calculations off to the side. So I have 3.7 and 5. When you add or subtract decimals, you have to line up your decimals. So 3.7, this 5 has a decimal sitting right there. So that's the same as 5.0. And when I add them, I get 8.7. So I'll put 8.7 right there. And then in my usual form, I'll just bring down whatever I haven't used. Haven't used that. Okay, and now the signs are different. So we will subtract, keep the sign of the larger. Certainly going to be positive. And again, when you subtract, you have to line up your decimals. Okay, so we have, I guess I can put it right here. I have my 8.7. I'm going to subtract 57 hundredths. You line up your decimals. Okay. And I can't subtract 7 from air. So I'll need a 0. Notice I didn't change the value of 8.7. Okay, I could add zeros all day long. It's still basically 8.7. And now I can borrow from the 7. And that's 8. So we end up with that decimal real clear. That takes care of 48. Let's take a look at 49. Simplified by combining like terms. Okay. Like terms have the same variable and exponent. The exponent's not even written, it's a 1, so not much mystery there. Let me use a different color pen. So this positive 16.5x and negative 9.8x, those are like terms. So when I combine them, the signs are different. I'll subtract, keep the sign of the larger. So that has, let's see, what do we have? 16.5, 9.8. So we get 6.7. And the x just comes along for the ride. Okay, so that's our variable term. And now these numbers are like terms as well. Okay, so I have a negative 8.7, a positive 17.8. The signs are different, so I'll subtract and keep the sign of the larger. It's going to be positive something. So our 17.8, 8.7. So we get 9.1. Okay, and that's our answer. That takes care of 49. And before we start on 53, will be the next one that we'll do, I want to draw your attention to this final answer. Notice I didn't solve for x. All I did was combine like terms. Okay? There's no equal sign here. There's no equal sign. I can't solve for x. Down here, 51, 52, 53, etc., there is an equal sign. So I can solve for x. All I have to do is figure out how to get x all by itself, and then I solve for x. If x is all by itself, whatever's sitting on the other side of the equal sign, that's what x is. All right, so we're going to do number 53 here. All right. I want x all by itself. I have this 5 here, but it's outside parentheses. I want to get rid of this negative 1.1, but it's trapped inside parentheses. So I really have to get rid of the parentheses. You do that by distributing whatever's in front. 5 times x gives us 5x. 5 times a negative 1.1 will be a negative 5.5. And then you just bring down whatever you haven't messed with yet. So that is the equal sign and the 9.3. Okay. I want to get x all by itself. I want to get rid of this 5.5 and also this 5. In general, it's easier to get rid of things that are being added or subtracted, especially in this class. So I want to get rid of a negative 5.5. It's held there by addition or subtraction. So that's the operation I'll use. The opposite operation is achieved with the opposite sign. So I put plus 5.5 on each side of the equal sign, and then just take a look and see where I'm left. Just draw a line here and bring everything down. This 5x is still sitting here. That's a 0. In this case, I don't have to write it. Wouldn't have much meaning, plus 0. And then over here, the signs are the same. So we'll have, and that'll be 14. Okay. One more step to get x by itself. You got to get rid of that 5. It's held there by multiplication. So the opposite is division. If I divide one side by 5, have to divide the other side by 5. And 14.8 divided by 5, don't forget to tell the world about that decimal, goes in there twice. Bring down your next digit. Goes in there 9 times. 3 left over. I am free to add digits. I can add zeros all day long. I'm not going to need all these, but I'm just emphasizing I can put in all the zeros I want. Bring down that 0. 5 goes into 30 6 times. That's a sorry looking 6. There we go. And obviously there's nothing left over. So over here, 14.8 divided by 5 is 2.96. And here's our equal sign. And 5 divided by 5 is 1. So you have x equals 2 96/100ths. Taking a look at 54 and 56. Let me zoom out for a second and say something about the directions on these. Well, at least 54. And again, I'll have to zoom out to be able to read all this. All right. They're saying to solve the equation by multiplying both sides by an appropriate power of 10, and that way we can get rid of our decimals. Basically, I'm just going to solve the problem by putting up with the fact that I've got decimals. Okay, I think it's important to learn how to deal with them because you'll be using them throughout mathematics. But briefly at the start, I'll show you the trick they're talking about. if I was to multiply this by 10, I would have 12. If I multiplied this by 10, I would have 7. If I multiplied this by 10, I'd have 145. So that would get rid of all my decimals. In order to do that, though, I have to do it in a balanced way. Okay? I can't just walk up and multiply one side of the equation by one thing and the other side by something different. You have to always be balanced. So what I'm really going to do is multiply this side by 10 and multiply this side by 10. But something you probably haven't seen is when you multiply or divide, you have to multiply or divide everything on each side. So let me go ahead and zoom in a little. I'm really going to solve it. Alright, so we'll multiply each. I multiply each side of the equation by 10, but that really means I multiply each term on each side by a 10. Alright. So each term on this side is going to get multiplied by a 10. Each term on this side is going to get multiplied by a 10. So that would give me 12x. This would give me a 30. This would give me 7x. And this would give me 145. Alright. These signs didn't go anywhere. I just didn't bother writing them as I was going along. So this sign is still right here. This sign is still right here. Perhaps you would combine like terms. Alright, I'll go ahead and solve it this way. I'm going to come back and solve it just putting up with these decimals, because you really need to learn how to deal with the decimals. But anyway, I've gone this far. So I can combine these or like terms. That gives us 5x minus 30 equals 145. Get rid of your 30. Five x is 175. Get rid of your 5. 5 goes into 5 once. You've got x equals 175 divided by 5 is 35. All right. So when we solved it this way, we saw that x equals 35. But again, my preference is just put up with these decimals for now. So I'm going to come back and solve it that way. All right. So let's get rid of these guys. A little bit of protest here from my equipment. All right. You want to clean up one side of the equation if you can. That's always a good idea. So let's combine our like terms. I've got, these are both like terms. They both have x to the first power. So 1.2 and 0.7, just off to the side, 1.2 and 0.7. That'd be 1.9. I did not mean to do that off screen. All right. So we have, whoops, that's negative, isn't it? Can't go that route. So I'm supposed to be subtracting. Sorry, folks. It's positive 1.2, and that's a negative 0.7. So the signs are different. I subtract and keep the sign of the larger. So I end up with 5/10. All right. So I have x, and now I'll bring down whatever I haven't touched, which is my negative 3 and my 14.5. And now let's get rid of our 3. It's held there by addition or subtraction, so I'll use addition or subtraction, but just the opposite sign. So I'll say plus 3 and plus 3. I need to line up my decimals. That's really 3.0, okay? And just draw a line here to subtract, or to bring down what's left. I have still 0.5x. That's a 0. I don't have to write it. Here the signs are the same, so we're going to add, and we have 17.5. And we're trying to get x all by itself, so I want to get rid of this 0.5. It's held by multiplication, so the opposite is division. Okay, and obviously that's going to clean up very quickly. That goes into itself once. You have x equals, and you have a little calculation here, okay? So that's 17.5 divided by 0.5. You can't have a decimal in front. You move it one place to keep it balanced. You move this one place as well. Put in your decimal. Tell the world. 5 goes into 17 3 times. Bring down your next digit. 5 goes into 25 5 times, and that would be 25, all right? So x equals 35. Notice we got the same answer. Slide this down, okay? So we ended up with 35 either way. This method showed multiplying each side of the equation by 10. This method showed just putting up with the fact that you've got some decimals and just do your calculations. Okay. So let's see, that's 54. We'll also take a look at 56. By the way, on 56, if you were going to try to get rid of your decimals by multiplying each term by, in this case it would be 10, you're going to have some trouble here because you can't get to the stuff inside parentheses. You would first have to distribute your 7, get rid of your parentheses, then you could multiply each term by 10. But again, I'm just going to deal with the decimals in this case. And basically in the same situation that I have to distribute this 7 before I can really take care of anything else. So 7 times 3 is 21. X comes along for the ride. 7 times 0.4 is 2.8. And then I just bring down whatever I haven't touched. So I have okay, and I want to get x all by itself. Well, I have a problem. There's x on each side. So I'm going to choose to get rid of this one, but at this point I could get rid of that, get rid of that, get rid of that, or get rid of that. But I'm most concerned with my variable, so that's what I work on first. And I'm going to get rid of the smaller one in hopes that I end up with a positive value. So this 3x is held by addition or subtraction, so I'll get rid of it with addition or subtraction. And you achieve the opposite operation by combining it with the same thing with the opposite sign. So this is a positive 3x. Here's negative 3x. Do the same on the other side. And now let's just see what we're left to deal with here. So this leaves us with 18x. We still have our minus 2.8 or negative 2.8, however you choose to say that. And here you'll probably say negative 2.8. Okay. I want x all by itself. I need to get rid of this negative 2.8. I also need to get rid of the 18, but in general, and in this class in particular, it's always easiest to get rid of the things that are being added or subtracted first. It's almost like you're considering things in the reverse of the order of operations. You know how addition, subtraction are the last things you do when you're strictly following order of operations. So for algebraic equations, it's almost like you do them in reverse. So anyway, I want to get rid of a negative 2.8. Here's a positive 2.8. Here's another positive 2.8. Have to do the same thing on each side of the equal sign. And this leaves us with 18x equals 0. You know, usually when I have a 0, I don't bother to write it. For instance, up here I had 3x and a negative 3x. That gave me a 0. I didn't write it because I didn't need to write it. I've got something else on this side of the equal sign. But when I get down here, if I don't put in this 0, there's nothing on this side of the equal sign. I can't have air over here. I need a number. Well, I've got 0. All right, I still want to get x all by itself. I want to get rid of the 18. It's held by multiplication. The opposite operation is division. Divide by 18. You always have to do the same thing on each side of the equal sign. And 18 goes into 18 once, so I have x all by itself, and 0 divided by 18 is 0. So that's your answer. X is equal to 0. And let's see. That'll take care of it.